All right, so pardon my voice, but we're going to look at various uses of the counting principle and probability. So, look at question number 1. And some of these you really have to kind of read what they've given you to see what your possible sample space is. Remember that normal probability is favorable over total possible outcomes, right? And a lot of this does delve on the counting principle. It's not all just multiplying everything together. It depends. So for the first one, it says 8 pieces of paper are numbered from 1 to 8 and placed into a box. One piece of paper is drawn from the box, its numbers written down, and the piece of paper is replaced in the box. Is that important? Yes, very important. Remember, with replacement versus without replacement. If I'm going to choose a second piece of paper out of that box, the fact that we've replaced the first paper is huge. Because that means that every time I reach in to take a number out of that box, I always have 8 numbers in there, 1 through 8, right? Mm-hmm. But if I do it without replacement and I set the number aside after I've used it, then I always have 1 less number in the box, and you have to know which numbers you've used, because then that might affect how they ask the question. So the fact that it's replaced means that it's an independent event. So however many times I take a number out of the box, the denominator, the total sample space available, is not affected. And then it goes on to say, then a piece of paper is again drawn from the box and the number is written down. Finally, the 2 numbers are added together. The question is, how many different ways can a total of 12 be obtained? Now think, I've only got numbers 1 through 8. I want to come up with all the possible combination for the first drawn number and the second drawn number. So if I draw a number of 1 and put it in the box, can I draw another number that's going to give me a sum of 12 with 1? No, because my highest number is 8, so 1 plus 8 is 9. All right, so 1's not going to be a possibility. What about 2? 2 plus my highest number of 8 is 10. Still not there. How about 3? 3 plus 8 is 11. Still not there. How about 4? So if I draw a 4, what would I have to draw for my second number? 8. I would have to draw an 8. All right, so then what if I drew a 5 for my first number? What would I have to draw for my second?
7.
A 7. If I drew a 6 for my first number, what would be my second? Now this is important. I can replace the number back, right? So can I draw the 6 again? Yes. Because of replacement, I can draw the 6 again. If we had no replacement, I would not be able to draw the 6 again, and 6, 6 would not be a possible combination, right? What about 7? My next number would be 5. And what about 8? And then that's my last number that I could draw, right? So how many total possibilities do I have?
5.
1, 2, 3, 4, 5 possibilities. So you might want to put on here, since these are your notes, these are the only possibilities that add to 12. And so the question actually says, how many different ways can a total of 12 be obtained? They're not asking what's the probability, are they? They're just asking how many ways. So therefore my answer is going to be 5 ways. So make sure that you know what is the question that they're asking. Don't assume that you know what it is. Now they switch it up a little bit. Now without replacement. So we know the combinations from the 8 numbers that add up to 12, right? So without replacement, you might want to write yourself a little note here. Since you can't choose 6, twice, right? There is one less option. Our assumption is that we're only drawing a paper twice. So the fact that all the rest of these are different means that they all have possibilities of being drawn. So my possibilities listed would be 4 and 8, 5 and 7, not the 6 and 6, 7 and 5. A draw of 5 and then 7 and then 5 are considered two different draws, even though they're the same numbers, and same thing with the 8 and the 4. So again, I have just 4 ways this time. Okay, so flip. So we have on here the fundamental counting principle, which says find the number of events happening and then find out how many ways each event happens and multiply those events together. So you could have, 100 events occurring. You'd have to multiply 100 things together. So M would be the probability of event 1 occurring. You're going to multiply to that the probability of event 2 occurring. And then you might want to write yourself a note that M is the number of times an event can occur. So this is straight from freshman math. The first thing I would do would figure out how many things do I need to know. Am I trying to find a 5-digit combination? Am I trying to find a 7-digit phone number? Am I trying to find a license plate that has 7 digits, some letters, some numbers? The first thing I need to know is how many things am I finding? So in example 2, how many ways can you draw 2 letters from the alphabet? It doesn't say anything about replacement or without replacement, does it? Okay, so it's kind of a vague question, not the best written question. So we're going to have to make a few assumptions. First of all, I'm drawing 2 letters, and I know I'm multiplying in between. How many letters are there in the alphabet? So 26. If they said that I couldn't repeat the letters, so I couldn't have AA or CC, then what would I put for the next one? 25. They haven't mentioned that I can't repeat letters, so my assumption is that I can repeat letters. They're not talking about drawing letters out of a hat or anything like that, so they didn't talk about with replacement or without, so we just assume that there's 26 possible unless they said that you can't repeat them. And so then your answer is going to be 26 times 26, and for your notes you might want to put first letter and second letter, because you might forget later where that came from. And so if you multiply 26 times 26, you get 676 total ways. That's a lot. Now, example 3 says, how many different phone numbers can you get? You can't use 0 or 1 in the first position. Again, somewhat vague, but if you were to give somebody your phone number, especially in this day and age, this would be different if I were sitting in that chair 25 years ago when I was in high school, give or take a few years. Why would I say that? How is my phone number different now than it was then? It has the same amount of numbers, but all of Scottsdale, let's say, all of Scottsdale, actually all of the Phoenix metro area had the same what? Area code. It really stressed me out when they changed area codes. Big time. Stressed me out. Then it stressed me out when I moved and I had to change area codes again. But now, we don't have to change area codes, do we? Unless it's your landline phone. Your cell phone, you can keep the area code, right? So we do have to take into account our area code. What we're not going to take into account is that we dial 1 first. Because what did they say? You have a 0, 1. Our assumption is then that we're not doing 1 times the area code times the prefix times the suffix. So how many digits after the area code are in a phone number? 7. So I have, here's my area code, and then here's, so I could put parentheses there, and then here's my 3 numbers, and then 1, 2, 3, 4, I'm running out of room, right? Now, that's going to give us a whole long thing, isn't it? So if I include the area code, it's going to give us even more possibilities. Could somebody with a different area code have the same phone number as you? Yes. So I'm going to do this two different ways, one with the area code, one without. If I can't use, they're assuming the 1 or the 0 in the first position is this right there, not your area code. I'm not a real traveler of phone numbers and area codes. I don't know if there's an area code that starts with a 1. I doubt it. Why? What are ones and zeros used for? Anybody know anybody? Country codes, right. If you ever, I never call anybody outside the United States because I don't know anybody outside the United States because I'm a sheltered person. But there's a lot of you that have family outside the United States, whether it's Canada, Mexico, over the big Atlantic seas, right? You want to learn to use Vonage, don't you? Cheaper, right? But anyway, you do have to dial a country code in order to do that. And what's in a country code typically? A 1. So there's 1s involved in there, which is a big reason why they won't let you use a 1. So we're going to do this first with just the area code. So if I can't use a 0 or a 1 in the first position, how many options do I have there? 8 only, right? Because there's 9 digits, or not 9, there's 10 number digits. 0 through 9 gives you 10 number digits, right? So then won't the rest, you know, I could have a phone number that's 222222222, right? I didn't count, but I 2222222. Is a propane company? Fascinating. So you actually can have that, right? Now, there's several different area codes that can have that phone number, right? So then the rest of them would be 10, wouldn't they? And I'd be multiplying all of these together. I put a dash there. It doesn't really mean subtraction, doesn't it? Because with phone numbers, you have to dash. And then times 10, 10, 10, and then 10. So without the area code, I would have how many possibilities? 1, 2, 3, 4, 5, 6. I would have 8 million possibilities, wouldn't I? Now, with an area code, and let's just assume for chuckle's sake that there could be a 1 in the area code. I don't know if that's true. I haven't looked at all the area codes. I know there can be a 0, right? 602 is one of ours. Let's just assume for chuckle's sake and for ease of math's sake that you can have a 0 or a 1. Wouldn't this be a possibility of 10, 10, and 10? So you take the 8 million possibilities here and multiply it to 1,000, and you come up with quite a very large number, don't you? So area codes are very important. What if we run out of numbers? We might be sitting on top of each other, but what if we run out of numbers? It's possible we could run out of numbers because you've got a landline, a cell phone, right? There used to be 1 phone per household. In my house, there's 5 telephone numbers, a landline and 4 cell phone numbers. Plus my husband has a work cell phone, so that makes 6. Okay, so each person can have more than 1 phone number associated with their name, can't they? Is it possible that we could run out of 8 million phone numbers? Well, it's possible. I don't know when. What was your question?
Do fax lines count? Because it's like the same as
I don't know the answer to that question. I imagine that a fax line has a different phone number than a landline also.
Oh, yeah.
But they run obviously through a different line. But yeah, that would be in there too. Yes?
Does the 8 have any answer? Why is it 8?
The 8 because the first position can't have a 0 or a 1 in it. So instead of this being a 10, it becomes only 8 possibilities. Because I can only have 2, 3, 4, 5, 6, 7, 8, or 9.
Okay.
I can't have the 0 or the 1. Does that make sense? And then here, this will give me 8, 1, 2, 3, 1, 2, 3, 1, 2, 3. What's that? 100,000 million billion, right? Possibilities. Just add another number or two, right? Oh yeah, phone numbers with my grandparents used to just have letters and numbers. It was like 5 numbers or 5 letters and number combination. Yeah, but that didn't last very long. But usually you might have a phone, one phone for every maybe 5 houses. Not everybody could afford a phone back then. Correct. A lot of people are giving up landlines. The only reason why I have a landline is for my security system. All right, so let's look at definition of a permutation. So we've talked about, didn't we talk about how to tell the difference between a permutation and a combination? Bless you. On one of them, order matters. What was the thing? I don't remember if I talked to you about this. I think I did with this class. Do you remember what I told you, how you can remember that? All right, I've been trying for years to get my, I'm an 80s girl, grew up in high school in the 80s. We had permanents. I could get really big hair with a perm. My hairstylist will not give me a permanent at all, period, whatever. I'm like, really? Okay, then I discovered the ceramic curling iron, which is fine. It still doesn't give me hair like a perm. Would it make a difference if my hairstylist did ordain to give me a perm, which she won't, but neither here nor there. Would it make a difference if she put the chemical products on my hair first and then curled it? Or is she supposed to curl my hair first and then put the products on? I know you guys are going, I have no idea. But what has to happen? Y'all have never had a perm, have you? I grew up with Tony perms. My mother used to burn my hair off with Tony perms. Okay, you have to curl the hair first and then put the solution on. Otherwise, it won't keep the hair. So, a hair permanent. Yeah, that was it too. You can't shower either. A hair permanent, it makes a difference on your order. So I want you to think of a permutation like hair permanent. And by the way, boys did get hair perms in the 80s. It was hysterical. Pretty darn funny. Little poodle heads. Little poodle heads, no. Yeah, but he's probably natural.
No, I don't know.
Really?
It's bigger than his head.
I'm thinking, no, it's natural.
I don't know if
Yep.
it's
All right, so a permutation is like a hair permanent, order matters. But a combination, order doesn't matter. You do not want to think of a combination like a lock combo where order does matter. Think that that's just quite the opposite. All right? So the permutation, the big thing is that, well, it doesn't say so in here, but if I were you, I would write order matters. So you have to kind of decide with a problem, does order matter? If I choose 5 of you to be on the math club, because I know you're all dying to be on the math club, and I don't give you separate jobs, and I don't give you separate jobs, then if I pick all the boys in this row and Danny, and I don't give them separate jobs, does it matter if I pick Danny, then Joey, then Omar, and Sam? Or can I do Omar, Sam, Danny, and Joey? Is it the same group or is it a different group? It's the same group if I don't give them separate jobs. But if I say, Danny, you're the president of the math club.
Oh my God.
And Sam, you're the treasurer. So Sam's the treasurer. And then I go, wait a minute. Wait, Sam needs to be the president. And Danny needs to be the treasurer. Would Danny be upset that I took the presidency away from him?
Yeah.
Yes. So order would matter. So you can have the same kind of story, but there's one little twist where if I give everybody a separate job, order matters. But if you don't all have a separate job and I'm just grabbing at will, order doesn't matter. So one would be a combination, one would be a permutation. Which one would be the combination? With a job or without a job? Without the job, because order wouldn't matter. So let's look at example 4. I'm losing my voice quickly. Finding the number of permutations of n elements. How many permutations are possible for the letters A, B, C, D, E, and F? Does order matter? Does order matter in my, because it's saying how many it said permutations, didn't it? So they're kind of saying order matters, because this is a different order than if I went backwards, right? It's the same letters, but if I went backwards, it's a whole different order. So order does matter, right? So we're going to do a permutation of how many items? 1, 2, 3, 4, 5, 6. 6 items taken 6 at a time. Anytime that you have a permutation where these are the same, you tell me what the shortcut would be. Yeah, it's really a factorial, isn't it? Because your permutation formula is 6 factorial. This is supposed to be the bigger number, by the way, and that's the number that goes up top. Permutation is n factorial over n minus r factorial. So n is your bigger number. That's the total number of items you have to choose from. R is the amount of items you're actually taking from the total, Joey. So the bigger number goes up top, factorial. Subtract the 2, and that goes on the bottom. So look what happens. Don't I get 6 minus 6 factorial on the bottom? This is 6 factorial over what's 0 factorial? 1. So Paris is right. Can't I just do when these are the same? Just a factorial? This is no different than arranging books on a shelf, is it? Or CDs on a shelf, or place finishers in a race. If I had 6 place finishers, there can only be 1 first place. Okay, technically I know that you could have 2 people tied for first, right? Am I right? But then you don't have a second place, do you? And you have to go to third place. So don't get caught up in technicalities. So I would be going 6 times 5 times 4 times 3 times 2 times 1. This is my first, second, third, fourth, fifth, and sixth place. If I multiplied all those together, which I of course would allow you to use a calculator, you get 720 ways. I know the air conditioning likes to do that in the afternoon. All right, and then go to the back page. Oh, look there on the back page. What'd they give you? What'd I give you? Okay. There's the formula that I just taught you about, right? So look at the difference in this type of problem. I got 8 horses are running in a race. Would order matter? Yes. In how many different ways can 3 horses come in first, second, and third? Well, I have 8 horses running in the race. Let's think about this. Assume that there are no ties. Now we could do the permutation as we have it up there, but let's think about this. The shortcut would be I've got first place, second place, and third place, right? How many horses are available to place first? 8. Once I get a horse that crosses the finish line, how many horses do I have that can place second? 7. And then third? 6. So if you're talking about a race or something where you're getting first, second, third place and you're not using all of the things in your whole group, only do a partial factorial. So 8 times 7 times 6 is equal to 336 possibilities. So this is way 1. I just want to prove to you that we could use a permutation formula to do it the other way. No, you don't have to, but I just want to prove to you it does work both ways. So if I were doing a permutation, I have 8 horses and I'm taking 3 at a time. First, second, and third place finishing. Because order matters, that's why I'm using the permutation. And so for a permutation, wouldn't I have 8 factorial over 8 minus 3 factorial? So we've learned 8 minus 3 factorial is what? 5 factorial. So here's how I'm going to write it, because we're in pre-calc. We know what it means. So we're going to do 8 times 7 times 6, and I'm going to stop at 5 factorial. Do I have to really write the whole thing out? Why? We know what we're doing, don't we? Okay, so the 5 factorials completely cancel, and I'm left with 8 times 7 times 6. Isn't that what we just did before? And so I still get 336 ways. Either way we look at it. All right, so here we go. This one, however, is a little different. Distinguishable permutations. This time we have in how many distinguishable ways can the letters in banana be written? Banana. So here's your formula. You're, you're going to have n factorial. And n factorial is going to represent all the possible letters in banana. If I had Mississippi, we'd count up all the letters in Mississippi. That would go in the top. Then in the bottom, you're going to have n sub 1 factorial times n sub 2 factorial times n sub 3 factorial times dot 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 n sub k factorial. It could go on infinitely, and I'll tell you how we figure out what that is. You have to take each separate letter. So each different letter that you have to count up how many B's you have, how many A's you have, how many N's you have. We only have 3 different letters in banana, don't we? So I'm going to have 3 different factorials underneath here. 1 factorial for the amount of letters in each different letter. So if I were you for your notes, I would write the following. The word has 6 letters, right? If you count banana, we get 6 letters, of which one is a B. Everybody agree we have 1 B? How many A's? 3 A's. And how many N's? 2 N's. So what we're going to do is we're going to substitute in for n factorial the total number of letters in the entire word. So 6 factorial goes up top. And on the bottom we represent the different letters. So we have 1b. So technically I have 1 factorial. Does that affect anything at all? No, but that's where the b is going to come from. And then I have 3 a's. So I'm going to have a 3 factorial. And then I have 2 n's, so I'm going to have a 2 factorial. So I'm going to ignore the 1 factorial. And then you can't do 3 times 2 is 6 factorial, by the way. It doesn't work that way. So what I am going to do is 6, 5, 4. Out of these 2, isn't 3 my biggest factorial? Mm-hmm. So I'm going to choose to stop at 3 factorial. But then I'm going to write 3 factorial right here, and it comes from this one. And I'm going to put the 2 factorial as 2 times 1. And the reason why I did that is I took the biggest factorial down here so I could cancel it with as much of that as possible. So I'm going to cancel this 3 factorial with that 3 factorial. Everything in the denominator has to cancel with something in the numerator. Then this 2 can either cancel into the 6 or the 4, but not both. So you choose. I'm going to choose to cancel it into the 4. And that leaves me with 6 times 5 times 2 only. Everything in the denominator canceled out. It'd be much easier to do 5 times 2 is 10 and multiply that to 6, right? So doesn't that give me 60 distinguishable, squeeze it in there, ways that I could arrange the letters of banana. You just wish you were back in Sesame Street land, don't you? All right, last one, let's talk about combinations. Combinations means that order doesn't matter, right? So I already talked about that. Order does not matter. So here's your formula. How is it different from the permutation formula? What's the difference? R factorial is added in on the bottom. And what that does is it takes away the things that are doubled. Like it would consider when rolling dice a 2 and a 4 is the same as a 4 and a 2. Order doesn't matter with the sum of the dice, right? So the combination here is going to take away those doubles and only look at that as one combination. All right, so counting card hands. First of all, before we can talk about cards, it shocks me that y'all don't know what's in a deck of cards. So on the very back, that means that you have not been playing card games. You've been watching TV or heaven knows what you've been doing. But you have not been playing cards. It's a very important part of your childhood is play cards. Good girl. And this will help you in, yes, this will help you in Las Vegas. So, how many total cards are there in a standard deck of cards?
52.
My older brother used to play 52 card pickup with me. I was a younger sister, and he would beat me up if I didn't actually pick him up. Because he was much bigger than me. So you must know that there are 52 cards total. Then the cards are split into red and black. Half and half. So you have 26 red cards. Because I could ask you the probability of drawing a red card, and you have to know that that's 26 out of 52. And there are 26 black cards. Then the 26 red cards are split into what are called suits, 2 suits. We've got 13 cards in the suit of hearts. And we have 13 cards in the diamonds. And then we have 13 cards in what? Clubs. And 13 cards in spades. That's where that feeling or that saying, I'll take it in spades comes from. It's talking about cards. And then here's what's really important. You've got to throw away all card game knowledge. In mathematics for probability, face cards are not special. The ace is not special. It has a value of 1. So each of these has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have Jack, Queen, and King. You have 3 face cards and you have 10 numbered cards. You have to realize that every suit has 3 face cards. So how many face cards total? 3 times 4 is 12. How many numbered cards total? 40. So you can be asked questions based upon that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. And you have that for all of these. Huh? The Joker doesn't count as part of the 52 cards. I know in some games it might, but not for mathematical probability.
I actually read the other day why it comes.
All right, so these are face cards, right? And then these would be considered numbered cards. And write down here, just for chuckle's sake, that you have 40 numbered cards and you have 12 face cards. Now they could ask you, what's the probability of a red face card? What would you say? What out of what? 6 out of 52 and then reduce. You have 52 possible. All right, so then let's flip it over and look at what the question is on the back. So when you do your homework, you want to have that handy if you're not familiar with what's in a deck of cards. A standard poker hand contains 5 cards dealt from a deck of 52. How many different poker hands are possible? So how many cards are in the hand? 5. And how many do I have to choose from? 52. Does order matter? No, because I can arrange in whatever order in my hand as long as I have the right 5 cards, right? So because order doesn't matter, we have a combination of 52 items taken 5 at a time. So I've got 52 factorial up top over 52 minus 5 factorial, and then 5 factorial again, because combinations take out the extra combos. So I really have 52 factorial over 52 minus 5 is what? 47 factorial, 5 factorial. Which is the bigger factorial in the denominator? 47. So you're going to do 52, 51, 50, 49, 48, and you're going to stop at 47 factorial. Right? Because then you're going to put 47 factorial over here, so you can easily cancel it out, and then put your 5 factorial out here. 5, 4, 3, 2, 1. So the 47s cancel. And then 5 is going to cancel into 50 10 times. 4 cancels into 48 12 times. 3 cancels into which one? Well, you could cancel into the 51 or the 12. It'd be easier to cancel into the 12 4 times. And in the 2, you could cancel into the 10, the 52, or the 4. I'm going to cancel into the 4, so I end up with a 2. So I have a 2, a 49, a 10, a 51, and a 52. If you multiply all of those together, you get 2,598,960 total poker hands. Now that doesn't mean they're all good hands, right? That's your total. Now you might want to see, how many royal flushes would you have in there? Well, then you have to figure that out. We won't get that specific. But your homework is